Have you ever thought about the possibility that the future could influence the past? Sounds wild, right? But what if I told you that some of the brightest minds in physics are exploring this very idea? Welcome to the world of retrocausality, where time isn't as straightforward as we think. What if the decisions we make today could actually be shaped by events that haven't happened yet? Could this change everything we know about reality? Stick around and let's dive into the information paradox and see how the future could be rewriting the past. What are your thoughts on that? Retrocausality. Have you ever wondered if the future could actually influence the past? It's a mind-bending concept that's been bouncing around in theoretical physics for some time. This phenomenon is called retrocausality, and it's exactly what it sounds like. The idea that future events can somehow affect or change things that have already happened. Now, this may sound completely counterintuitive. We're all used to the idea that the past shapes the present, and the present shapes the future. It's a straightforward chain of cause and effect, but retrocausality flips that order on its head, and it might just be the key to unlocking some of the biggest mysteries of the universe. In quantum mechanics, retrocausality isn't just a theoretical idea. It's something that's been explored to explain puzzling phenomena. Imagine a world where actions in the future can affect what happens in the past, creating a feedback loop that challenges everything we think we know about time. For instance, quantum experiments like the delayed choice quantum eraser suggest that decisions made today can influence events that took place earlier in time. That's right. The future can sometimes shape the past. It's a fascinating thought. If retrocausality is possible, it could change everything. It would require us to rethink how we understand not just physics, but time itself. Could this be the missing link between the realms of quantum mechanics and the macroscopic world? Could retrocausality hold the answers to some of the deepest questions in science? The debate is ongoing, but one thing is clear: it challenges everything we know about reality and our understanding of time. The black hole information paradox. Let's dive deep into the heart of the universe, into one of the most mysterious and mind-boggling phenomena known to science: the black hole. These massive cosmic objects are so dense that not even light can escape their gravitational pull. But while they might seem like a straightforward concept, they are hiding a paradox that has confounded physicists for decades: the black hole information paradox. According to Einstein's theory of general relativity, once something enters a black hole, it is lost forever. Information about that object, whether it's a spaceship, a star, or even a person, disappears beyond the event horizon, the point of no return. But this creates a problem. Quantum mechanics, which governs the behavior of tiny particles, tells us that information can never truly be destroyed. It's a fundamental rule of quantum theory: information is always preserved. This contradiction between general relativity and quantum mechanics creates the black hole information paradox. If information is lost inside black holes, then the fundamental laws of quantum mechanics would be violated. On the other hand, if the information is preserved in some way, it would mean that something is happening inside black holes that we don't fully understand yet. Recent theories have tried to resolve this paradox. Some scientists propose that the information is not actually lost, but instead is somehow encoded on the surface of the black hole, in a phenomenon called holography. Others suggest that the information could be preserved in subtle quantum fluctuations near the event horizon. But for now, the black hole information paradox remains one of the biggest unsolved mysteries in physics. In short, black holes are more than just cosmic vacuum cleaners. They're like the universe's biggest riddle boxes. And understanding the information paradox could hold the key to unifying the two great pillars of physics, general relativity and quantum mechanics, in ways we've only begun to imagine. Retrocausality in quantum mechanics. Imagine you're about to make a decision, but instead of choosing in the present, your decision seems to be influenced by something that hasn't happened yet. It sounds like something straight out of a science fiction movie, right? But believe it or not, this concept, retrocausality, is being taken seriously by some of the brightest minds in quantum mechanics. Quantum mechanics, the branch of physics that deals with the behavior of the very small, is full of strange and bizarre phenomena. It's the world where particles exist in multiple states at once, where they can be in two places at the same time, and where the mere act of observing them changes their behavior. So it's not too surprising that retrocausality has emerged as a possible explanation for some of these mind-boggling experiments. One of the most famous quantum experiments that suggests retrocausality could be at play is the delayed choice quantum eraser experiment. In this experiment, scientists have shown that particles such as photons can behave like both particles and waves. What's even more puzzling is that the outcome of the experiment seems to depend on decisions made after the particles have already been sent through a detector. Essentially, the future seems to be influencing the behavior of particles that have already passed through the apparatus. This is like the future deciding how the past unfolds. This isn't just an odd quirk of physics. It challenges everything we thought we knew about time. If the future can affect the past, then our traditional understanding of cause and effect becomes meaningless. The implications of retrocausality could change the way we understand not only quantum mechanics, but the very nature of reality. Could time really be a loop? Could our decisions in the future truly ripple backward in time? Right now, physicists are still grappling with these questions, but the answers might just blow our minds. Temporal paradoxes and bootstrap paradoxes. What happens when time itself becomes a tangled web of paradoxes where events loop back on themselves and causality seems to lose its meaning? This is exactly what happens in the strange world of temporal paradoxes. These mind-bending scenarios arise when actions in the past influence the future in a way that creates an endless cycle, often leaving us wondering where it all started. One of the most famous examples of a temporal paradox is the bootstrap paradox. This involves an object or a piece of information that exists without ever being created. Let me set the scene. Imagine a time traveler who goes back in time and gives Shakespeare a copy of his own works. Shakespeare publishes those works, which the time traveler reads and then uses as inspiration to travel back in time again and give Shakespeare the manuscript. But here's the catch. The works exist, but there's no original author. The manuscript has no true source, creating a causal loop that seemingly has no beginning or end. How did the work come into existence in the first place? This paradox is not just a curious thought experiment, it's a fundamental challenge to our understanding of causality. It questions whether time travel, or any form of time manipulation, could be possible in a way that doesn't create these strange loops. Could the future and past be forever intertwined, or is there always a starting point where events begin? In addition to the bootstrap paradox, other temporal paradoxes like the grandfather paradox, where a time traveler prevents their own existence by altering something in the past, also raise questions about free will, destiny, and the fabric of reality itself. If we could travel through time, could we change history, or would we be forced to follow a predetermined path that avoids paradoxes at all costs? These paradoxes push the boundaries of our imagination and challenge the very concept of time as a linear progression from past to present to future. Philosophical implications of retrocausality. What if time isn't the constant, unidirectional flow we've always assumed it to be? What if the future could reach back and alter the past, causing a ripple effect that defies our basic understanding of reality? The implications of retrocausality are not just limited to physics. They stretch deep into the realm of philosophy, where they challenge our most fundamental ideas about time, free will, and even the nature of existence itself. One of the most profound questions raised by retrocausality is how it might impact the concept of free will. If future events can influence the past, does that mean our present decisions are predetermined by forces yet to come? Could our choices be influenced by things we haven't even experienced yet? This dilemma touches on the age-old debate between determinism and free will. If time isn't linear, how can we be sure that we're truly making independent choices, or if we're simply following a path set for us by future events? Furthermore, retrocausality forces us to reconsider the nature of cause and effect. Traditionally, we think of causality as a straight line. One thing happens, and then another thing follows. But retrocausality introduces a feedback loop, where effects can loop back in time and influence their causes. It's as if time itself could be bent, twisted, or even rewound, making us question whether time really flows in one direction at all. And let's not forget the deeper existential implications. If we accept retrocausality, what does it mean for our place in the universe? Are we simply actors in a play, following a script written by the future? Or do we have the agency to change the course of time, creating our own paths through a dynamic and ever-changing reality? These are questions that philosophers and physicists alike are still grappling with, and the answers may just redefine the way we think about the universe. Current research and perspectives. Although retrocausality might sound like the stuff of science fiction, it's a topic that continues to captivate the world of physics. In fact, ongoing research is challenging our traditional understanding of time, and some physicists are actively exploring retrocausality as a potential solution to some of the most confounding mysteries in quantum mechanics. One of the major areas where retrocausality is being explored is in the realm of quantum theory. Quantum mechanics has long been filled with paradoxes that seem to defy logic, particles that exist in multiple states at once, or that appear to communicate instantaneously across vast distances. Retrocausality offers a possible way to resolve some of these paradoxes by suggesting that the future could somehow guide or influence the behavior of quantum particles. Imagine a quantum system where the future somehow chooses the outcome of a measurement made in the present, creating a causal loop that connects past, present, and future in a way we never thought possible. But how exactly would retrocausality work? Some physicists propose that it could be linked to the idea of information transfer. In quantum mechanics, information plays a critical role in how particles interact. If future events can send signals or information backward in time, it might help to explain some of the bizarre behaviors we see in quantum systems. Others suggest that retrocausality could be connected to a deeper theory, one that unifies quantum mechanics with general relativity, two fundamental theories that until now have seemed incompatible. Despite these intriguing possibilities, there's still no concrete evidence to support retrocausality, at least not in the way we might hope. Some researchers are focused on designing experiments that could test the theory, while others are exploring new mathematical frameworks to see if retrocausal models can explain observed quantum phenomena. For now, retrocausality remains a speculative theory, but it's a theory that could change the entire way we think about time, causality, and the universe itself. As research continues, the possibility that the future can influence the past may one day become one of the most revolutionary breakthroughs in science. Thanks for joining me in this mind-bending journey through the information paradox. What do you think? Could the future really influence the past? Let me know your thoughts in the comments below. If you found this topic as fascinating as I did, don't forget to like, share, and subscribe for more mind-expanding discussions. Stay tuned for the next deep dive into the world of science and technology here on InnoVision Tech.